So looking at the limit as x approaches infinity, I'm going to take a look at the leading coefficient of the highest term and ignoring all the other terms. Same thing in the denominator. We look at the exponent of the numerator, the highest exponent of the numerator, it's equal to 3. And look at the highest exponent of the denominator, it's also equal to 3. Since the numerator and the denominator have the highest exponents are equal to each other, we look at the coefficients of the leading terms. Coefficient of the leading term for the numerator is 1. The coefficient for the leading term in the denominator is 4. So we'll be choosing 1/4 as our limit. Same thing in this problem, we're going to look at the limit as x approaches infinity. This time we'll have to distribute our terms to find out what our highest exponent is going to be to determine if we'll use those leading coefficients. After distributing, we're going to combine like terms and look at our highest exponent in the numerator and the highest exponent in the denominator. The highest exponent in the numerator is 2, so the exponent of the numerator is equal to 2, and the highest exponent in the denominator is also equal to 2. Since the highest exponent of the numerator is equal to the highest exponent of the denominator, we look at our coefficients when we're taking a look at the limit as x approaches infinity. We'll be using the coefficient of -2 from the numerator and 1 from the denominator. So that gives us letter choice B. In this problem we can use our calculator, but if we were to take a look at evaluating this limit by hand, we would take a look at that leading term, limit as x approaches infinity of just the square root of x squared, and the denominator would be -2x, ignoring the other terms. So reducing square root of x squared would turn out to be positive or negative x, and the denominator we still have -2x. Since we're looking at the limit as x approaches infinity, that'll be that positive value, so instead of keeping positive and negative x, we'll just have the positive version of x. So now as we look at the exponent of our numerator, we can see that's going to be 1. The exponent of the denominator is also 1. And since the exponent of the numerator and the denominator are equal to each other, again, we'll look at the coefficients. The coefficient of the numerator is 1 and the denominator is -2, so we choose B. Looking at the limit as x approaches infinity again, ignoring the other terms, choosing only the highest exponents, we're looking at the exponent of the numerator, which is 2, the exponent of the denominator, which is also 2. Again, since the numerator and the denominators are equal to each other, we're just going to look at the coefficients to determine the limit as x approaches infinity. Coefficient from the numerator is -1, and from the denominator is 4. So letter choice B. Now we're looking at the limit as x approaches negative infinity. Again, ignoring the other terms, just paying attention to those leading terms. The exponent of the numerator is equal to 3. The exponent of the denominator is equal to 2. Since the exponent of the numerator is greater than the exponent of the denominator, the limit as x approaches negative infinity is going to be either plus or minus infinity, so positive or negative infinity. So we have to determine will it be positive infinity or negative infinity. So we have to think about putting in x as we approach negative infinity, so some negative very large number. So choosing -1000 as that very large number, substituting that in and thinking through what would happen in the problem. We replace -1000 in for x. -1000 cubed is going to be a very negative large number. Down in the denominator, the -1000 squared will be a positive number, so we'll have a negative infinity divided by a positive number. So then we're going to be choosing A. So to take a look at this problem, we're going to have to eliminate some choices. Take a look at the vertical asymptotes. We'll set our denominator equal to 0. So setting the denominator equal to 0, we'll factor out a 4x, set each factor equal to 0 to get x is equal to 0 and x is equal to 1. So we have vertical asymptotes at x is equal to 0 and x is equal to 1, which eliminates answer choice A. Answer choice D is also eliminated, and answer choice E. So now we'll look at our horizontal asymptotes. To find your horizontal asymptotes, take a look at your exponent of your numerator and compare it to the exponent of the denominator. The exponent of the numerator is 2. The exponent of the denominator is also 2. So since the exponent of the numerator and denominator are equal to each other, we just look at the coefficients to determine where our horizontal asymptote will be. The coefficient from the numerator is 2. Coefficient from the denominator is 4. So at y is equal to 2 over 4, or y equals 1/2, we'll have a horizontal asymptote. So that gives us letter choice C.